Gregor is dividing 2015 by the numbers from 1 to 1,000, like dividing and then starting again and so on. And he writes down the remainder. What is the largest remainder? Well, I'm going to show you the quick way of doing this question, which I did not think about, but it is like so fast. And then I'll show you the way that I kind of did it, much like struggling through divisions and so on. So first thing to say is that, right, I'm just going to divide by 2 to start with. That would give me 1,007 with a remainder of 1. So I don't think that's going to win it. But why I'm given this is that this thing here is actually called the quotient, because I'm going to make reference to that. And this is the remainder. Just for info, 2 is called the divisor and 2015 is called the dividend. But I'm going to focus on these two words to be fair. Now, because we're dividing by, the largest thing that we could divide by would be 2050, would be 1,000. And that would give me 2, remainder 15. The reason I write that is that the quotient is going to have to be greater or equal to 2. So essentially, whatever I divide by, I'm going to get a quotient of at least 2. So let's go with the thing that's going to leave the largest remainder. Well, it's going to be when the quotient is as small as possible. So I kind of want to write this down. So make quotient as small as possible, because then you can have a larger remainder. And let's let the divisor that we're going to divide by, we're kind of interested in this. Let's let that equal d. So when I divide by d, I'm going to get the smallest possible quotient, and then I want the largest possible remainder. Now, if you divide by 2, for example, you can never get a remainder of 2 because you would just actually, you can divide 2 by 2. So and if you divide by 37, you can never get a remainder of 37 or more. It's going to have to be less than. So to get the largest remainder, we're going to pick the divisor that leaves a quotient of 2 and then leaves a remainder of d minus 1. Just one off the divisor. So we can nearly divide into it 3 times, but not quite. That's what I'm arguing here. Okay, and this is this is the quicker but more complicated method to understand. So I haven't, because that's the remainder, I've not actually divided it by the divisor, so I need to write it like that. And a way of thinking about it over here is that this 2015 divided by 1,000 would actually be 2 plus 15 over 1,000, because I've not actually divided that 15. It's the remainder. It still needs to be divided later on. So I've written down an algebraic equation. Multiply through by d. 2015 is equal to 2d plus d minus 1. You might be able to go straight there. I like to write this down first. But what I've got now is an equation to solve. 3d is going to equal 2016. And then let's see if that has a solution. Well, the digit sum is equal to 9, so it is necessarily going to go into it. 3's into 2016. So basically sorry, let me just finish this. 6, remainder 2, 7, 2. 6, 7, 2. Basically, if we had one more, we added one more to 2015 and got 2016, then this number would go into it 3 times. So actually, it doesn't quite go into 2015 3 times. It goes into it twice, and then you get the maximum remainder. So the maximum remainder is going to be d minus 1, remember, which is 671. And that is our answer. Let me show you how I did it now, and this is not a good way actually, but it got me the right answer. But really, I'd say, hey, look at this and make sure you understand it. So when I did it, I used essentially the idea that 2's into 2015 are going to go 100, sorry, 1,007 remainder 1. But what that means is that 1,007 into 2015 is going to be 2 remainder 1. Okay, that's a very small remainder. But what if I divided by the next number on, 1,008? So 1,008 Right, because I had a remainder of 1, now I'm not going to be able to get a quotient of 2. I'm only going to get a quotient of 1. And they're going to be left with a remainder of 1007. So actually, I think out of every single number that we could pick, this the largest remainder would be 1007. However, we are told that we are only dividing by numbers up to 1000, so I'll reject this one. Yeah, I can't actually obtain that remainder because this is greater than 1000. But it kind of sets me on the right path. So what about if I do 3's into 2015? I'm going to get 6, 7, 1, remainder 2, which means that 671 into 2015 is going to give me 3, remainder 2. So again, if I increase that by 1, 672, now I want like an extra 3 essentially. I'm not going to be able to get it. I'm going to be left with 2 and then a remainder of 671. And this is okay. This number is less than 1000, and I've managed to get a remainder of 671. Now, if we divide by um, anything larger than that, then we're going to get a quotient to, well, but less than 1008. Then I'm going to get a quotient of 2, but the remainder is definitely going to be smaller because um, I'm gonna have less remainder because I've got more. The quotient is kind of used. I've got 2 times say 700. That's going to be 1400. So I'm going to get less remainder. So that is one way of alternative way of arguing that it's 671. And we don't need to carry on. We don't need to say divide by 4 because we're definitely going to get a lower remainder from that as well. This method, it's not as good as it. It's a bit more wishy-washy, I think. I haven't quite wrapped my head around the fact that have I really comprehensively proven that that is the largest remainder? It's a bit like, yeah, I'm just trying some things out and I've managed to get this answer here, so it must be okay. But like I said, this is the one to go with. But yeah, good to see 2 methods, I suppose, and I'd be interested to see here if there are other methods. Thanks.